guys, here's your video for Friday's class since we won't be meeting. I did want to back up and kind of go over the last part of 2.3 since we were rushed when we met on Tuesday. So on Tuesday, we kind of finished up with the idea of function notation, and I want to bring up a couple of reminders. So remember that f of x, that notation is the same notation as y. So the x is inside the parentheses right here. That's the input. But if you're looking at the whole notation, then you want to make sure that you realize it's the output. So if we're looking at f of x as a whole notation, f of x, that means it's the output. So it's very important that we understand if you're looking for the input or the output. Now, the next slide is going to show us what we saw in class, but I want to make sure because most students end up really struggling with this. Because there's no x here, this means the same as x is equal to 4. This means the same as x is equal to 0. Now remember, I said that you could think of f of x as y. So this could be y equals a -2, and this could be when y is equal to 0. So if x is equal to 4, you go across the x-axis, and then you go up till you hit the line right here. Then you go across to find out how high you are, which is 3. So when x is 4, y is 3. When x is 0, you go up, you hit it at 1. So y is equal to 1. When we want y is equal to a -2, we're using the y-axis, so we start here. We go over till we hit the line and we go up, and we realize that that happens when x is equal to a -6. When y is equal to 0, we start at 0, 0, we travel across to the line, and when we do that, we find that x is equal to a -2. So it's important that we realize what we're looking for, the x value or the y value. So what's inside the parenthesis, our author reminds us, is the explanatory value, the independent variable. I'll write independent here with my mouse. So that's the independent, often known as x, but it's not always x. And this is the dependent. It's dependent on what we do. And it is the y variable typically, although it does not have to be. So as you're going forward, keep that in mind that we have the response variable, the explanatory variable, and the f is just simply letting you know that it's a function. So we covered this briefly in class on Tuesday, but I want to make sure that it's clear. So when you're using an equation to model predictions, we have to make sure that we solve for that variable. We want to make sure that the prediction about the explanatory variable is substitute a chosen value in and then get the output. So the first thing you should do is construct a scatter plot. Remember what this means. This means go into edit and fill in L1, L1 and L2. So you're going to fill in the list so that you can make the scatter plot. Remember, you might have to turn in stat plot. Here, when you find the equation, we are going to use linear regression. Sorry, this does not want to write well today. So linear regression, it likes my cursive better. That is under calculate and then go to the number 4. And that will say linear regression. So as we are going down to the third step, you're going to verify that your equation by plotting and graphing both the scatter plot and the equation and make sure that it is close to as many points as possible. Then and only then should you use the equation of your model to make estimates, predictions, and draw conclusions. So let's go back to this example here. I will have you input the information in L1 and L2 and put this in your calculator. And so pause the video here and come back when you're ready. Okay, since the years are since 1900, you will want to make sure that you have a column T for time, and in that you have 70, 80, 90, 100, and so on in your L1 list. L2 is going to have all of this data. So we want to make sure that you have that in L1 and L2. Please take a picture of your calculator screen now and be prepared to include it in what you send me as your end document. Next, we worked a little bit on this in class, so it may be in your notes, but I thought we felt rushed. So we're going to go and find, number 2 says we're going to find G at 121. So the input variable T is 121, and we're going to find out what the result means. So in our writing, T is equal to 121. So we know in the equation, that's where T is. So that's where you're going to substitute 121. And your answer should be in the form P equals. Next, they want you to evaluate G of T equals 30. Remember, T is the input, so now it's saying, oh, P equals 30. And you are going to substitute where you had P before. So P equals 30 has you putting the 30 where P is and solving for T. Whenever you're finding an intercept, p-intercept, that means the opposite variable is equal to 0. And when you're finding the t-intercept, that means that p is equal to 0. So now you're substituting those in and finding your answers. The key here is, can you really describe what it means once you've found the answers? So I would like you on a piece of notebook paper or Word document to complete your work on 2, 3, 4, and 5 at this time and pause the video. When you've completed that work, come back and press play. Okay, welcome back. So just remember that when we're finding the intercepts, as I mentioned before, you're always looking for the opposite value to be equal to 0. So keep that in mind, that if you're looking for the t-intercept, p is equal to 0. If you're looking for the p-intercept, t is equal to 0. So let's take a look at this. A store is open from 9 to 5, Mondays through Saturdays. Let the I be the employee's weekly income from working T hours at $10 an hour. Find an equation to model this. Well, if you look down here at the bottom of the slide, you can see that the function is going to be 10 times every hour that they work. So f of t is equal to 10 times t. Now, they're asking us to find, sorry, I had an interruption. So as we go through this, we're looking for the domain and the range. Remember, domain are all the values of x, and range are all the values of y. In this case, we don't have the variables x and y. We have t as the independent, or what we like to know as x. So in our mind, we are looking for t and what values it can be across the horizontal axis. Well, if t are hours that you can work, the minimum number that you could work would be 0, and the maximum number you could work would be every hour that the store is open. Every hour that the store is open is 48 hours. So we have 0 hours to 48 hours are the maximum times that we could possibly work. So when you think about your earnings, if you had 0 hours, you're going to earn 0 amount of money. If you work all 48 hours times $10 an hour, you are going to have $480 that you could possibly earn. So when we look at this, the domain is going to be across the horizontal axis, or 0 to 48. And we can see then that the maximum amount of money we could earn is 480. So that's how we would find the domain and range. Let's get into 2.4. 2.4 is going to talk to us about slope as a rate of change, which I've already started talking to you about that a little bit. The only difference between a ratio and a unit ratio is a unit ratio makes sure that the denominator is always 1. So that's how we talk about things in the real world. Miles per gallon, that's miles per 1 gallon. Miles per hour on our speedometer is miles in 1 hour. So it's easiest for the human brain and our conversations if we convert things to a unit ratio. So let's take a look here. Suppose that we're looking for a rate of change. We've done this with slope through lots of times. So we take the y2 minus y1 over x2 minus x1. Nothing new here. But let's try to apply this now, looking for a rate of change. So the enrollment at DeVry University declined approximately steadily from 82,000 students in 2012 to 37,000 students in 2016. Find the approximate rate of change in enrollment. Please pause the video here and do your calculation, and we will go over it as soon as you're finished. Press play when you are done. Since we know the students are changing from 37 to 82,000, and we know the year is changing from 2016 to 2012, we can do that subtraction, and we find out that we're losing 45,000 students in 4 years. That's kind of hard to wrap our head around, but if we say we're losing 11.25 thousand students every year, that becomes more clear. So we do want to put our rates of change where we have 1 in the denominator. So let's try another problem. This time we're going to talk about the median of homes, where we're talking about the median value of a home and the number of bedrooms in which that home has. It's a kind of a common statistic used in real estate. So in Phoenix, Arizona, the median value of a 2-bedroom home is $151,000. The median value of a 4-bedroom home is $274,000. So we are going to find the rate of change as it pertains to bedrooms. So we're going to say, if the money changes from 151 to 274, the bedrooms change from 2 to 4. So about how much could we expect to change every time we change for 1 more bedroom? So please pause the video, write this information down in your notebook before pressing play again. So you are going to find the rate of change for this problem. So the rate of change could be written out as 274,000 minus 151,000, all divided by 4 bedrooms minus 2 bedrooms. And you'll find out that it worked out to be $123,000 for 2 bedrooms. you can then simplify it to 1 bedroom. So every time you want to go up by 1 more bedroom, you can expect to add $61.5 thousand to the purchase price. So that will help you decide how many bedrooms you can afford. So now, looking at the signs of the rate of change, this is kind of intuitive. So if P increases steadily as T increases, so both things are increasing, we're going to have a positive rate of change. If one of them is decreasing as one increases, then we're going to have a negative slope or a negative rate of change. For our next problem, I would like you to put this data in your list 1 and list 2. So please clear out the previous data, put the appropriate data in, take a picture of your calculator screen so that you can submit it later, and press pause now so that you have time to put the data in before the next slide where it does not appear again. Thank you for coming back. Now that you have that data in list 1 and list 2, please create a scatter plot. Then use linear regression to find an equation of the line. Put both of those in your graphing calculator, and once on the graph where you can see the data points, the scatter plot that is, and the linear line that you found in your linear regression, please take another picture of your calculator screen. Now it's time to find the slope of our linear model. That should be clear to you if you used linear regression. The slope is always the coefficient in front of x. Our calculators call it the letter little a. So little a is equal to the slope. Now, it's asking you to find the rate of change in distance between a given period. So now you're looking at the slope just between 2 and 3 and 0 and 4. Compare each result with the slope of the linear model. So you're going to go back to your table and look at what the rate of change was just between 2 and 3 and between 0 and 4. Then compare that to your linear regression. Please note in your notebook what you find. Now, if we were to look at this on our screen, you should have something that looks like this. Sorry, it's skipping ahead on me, but that's fine. So comparing slopes, you're going to look at the slopes between 2 and 3, means you're also comparing the outputs between 120 and 180. So you find that the slope is 60. Now, you can also do it between 0 and 4. Between 0 and 4, you're looking at between 240 miles and 0 miles in 4 hours and 0 hours. That is 60 miles per hour also. So there's a linear relationship when the slope of the model is always the same. Otherwise, you're going to get a crooked, jagged line if you have different rates of change. So that is called a constant rate of change. The next model we're going to work on finding is a model of profit. So a company's profit is $10 million in 2010, and it increases $3 million every year. So you are now going to take a look at being able to find the linear regression. You know the slope is the rate of change. You should be able to find the intercept because T years since 10,000, and it already gave you what the value was at 10,000, and write an equation. Please label on your notebook this model and indicate the p-intercept, the slope, and then write the equation. You may pause the video here so that you have time to complete this. Next, we want to talk about unit analysis. Unit analysis is a model's equation determining the units of expressions on both sides. That is, we need to make sure that we're talking about the same things in one problem. So if a driver fills her car's 12-gallon gasoline tank and drives at a constant speed, this car consumes 0.04 gallons per mile. So we're going to let G be the number of gallons of gasoline remaining in the tank, and D are going to be the miles since she filled up. Do you think that this is linear? If you do, what is the G-intercept? What is the slope? And finally, what is the equation? When we ask you to perform unit analysis, your answer needs to be in units so that I know what you're talking about. Are you talking about cups per minute? Are you talking about gallons per second, gallons per hour, gallons per mile? So knowing the units is very important. Please pause your computer and answer these questions in your notebook and press play when you are ready to go. Now we're going to talk about analyzing a model. So the percentages of a Fortune 1000 board seats filled by women are shown for various years. So looking just at the table, you should see that the years are going up. So 2011 to 2016, how many women are sitting on boards of Fortune 1000 companies? Well, let's look. It looks like it starts out at 14%, going up to 15, 16, 17, 18, 19. So it's definitely increasing. So we know that our slope should be positive. So when we look at the model they gave us, P is equal to 1.03T plus 13.55. We quickly see that it's 1.03, and it is, in fact, positive. So if at this time you could write this information down, it will be useful as we progress to the next slide. So press pause here, write down the table in your notebook and the equation so that you're ready to answer the questions on the next slide. Press play when you are ready to begin. All right, thank you. Coming back now, we're going to use our graphing calculator to draw a scatter plot. And in the same window, put the equation that was given to you on the previous slide. Then answer these questions. What is the slope of the model, but what does the slope mean? Find the rates of change as percentage of seats filled by women from one year to the next. Compare the rates of change with the results found in what you said the slope was in number 2. The last part of this problem has you looking at 2020. Women on the boards has set a goal that women will fill 20% of the Fortune 1000 board seats by the year 2020. What does your model predict will happen in the year 2020? Please put this prediction down in your notebook, and along with it, write a sentence that states your model predicts in 2020 blank percent of women will fill the Fortune 1000 board seats. All right, we're almost finished up for the day. And here we go. We're going to wrap it up. Describe the meaning of slope. So it's a common error to be vague when describing the meaning. For example, you might say, oh, it's as much as it's changing, it's decreasing, it's increasing. Sometimes you'll even just say it's 4. Well, that's not appropriate when we're describing models. So you want to say something like the slope of 1.03 means the percentage of Fortune 1000 board seats filled by women is increasing by 1.03 percentage points per year. I hope you have a great weekend, and I will see you Tuesday in the classroom so that we can go over all of your questions. You have time now to complete your My Math Lab homework up to and including, hopefully, 2.4 before class on Tuesday. Have a great weekend. Stay warm.